Hi everyone, this is Mrs. GA, and today we are going to learn about circles. So I have a quick warm-up for you guys, so please pause the video and give these a try. Alright, go ahead and check your work here. So for part A, we have a horizontal parabola opening to the left. So our vertex is directly in the middle of your focus and where your directrix is. So your vertex must be at 3, -4. And your p-value is -1/2, so you get this equation. And then here, given where our directrix and our focus are, we can see that we have a downward facing parabola, and our vertex again must be halfway in between. So if you find the distance in between your two y values and you divide it by 2, that distance, the distance divided by 2 is 3/2. So that's going to be your p-value, but it is negative because it is facing down. But that is going to be the distance from your vertex to your directrix or your focus. So to get your vertex, you can start at the directrix and you can just subtract 3/2, and that's where your vertex will be. So you get this as your equation. Okay, so today we are going to be graphing and working with equations of circles. So before we look at how to do this, we're actually going to derive the standard form of our circle equation. So to do this, let's start by sketching a circle like this. And any quadrant is fine. So all circles have a center. So we're going to call this center point, we'll call it HK. So very similar to the vertex of a parabola, but for the center we call it HK. So then let's take, we're going to actually take a point that's on our circle, okay? So for this point, let's just call it XY. This is any point on our circle. So one thing we're going to want to describe here is the radius of our circle, which we'll call R. Now, to find this, it would be nice if we could maybe turn this line into a right triangle, because then we could define R using the Pythagorean theorem. So if we make a right triangle here, we need to find a point that is perpendicular to the 2 points we already have. So if this is, these are both perpendicular lines, and we go to actually name this coordinate. So the x value of this coordinate is going to be the same as the x value of this coordinate, because again, they're along the same vertical line. So we could say this is x. And then the y value of this coordinate is going to be the same as the y value of our center. So we'll call it k. Again, the x value of this coordinate is the same as the x value of the coordinate on our circle, and the y value of this coordinate is the same as the y value of our center. So now here we can actually use these coordinates to help us find the length of our two legs. So I'll just call this A and I'll call this B. So for A, if we want to describe that length, again, it's just going to be the difference in the x values. So it's going to be the difference because it's a horizontal. So it's going to be the difference of your x values. So we'll say x minus h. But here technically, we don't really, this circle could be anywhere, and xy could be any point on your circle. So in this case, I can see that it looks like x is positive and it looks like x is larger than h, but really we don't know. It could be any point on your circle. So just to be sure, if we put absolute values around it, it ensures that it's a positive distance, and we want it to be positive because we're finding the leg of a triangle. And now if we want to find this length, B, well, this length is just going to be the change in y values, so the distance from this y value to this y value. So we can say y minus k. And again, just to ensure that it's positive, because again, we don't really know what y is. Y can be any point on your circle. We'll put absolute values around it. So now we have a way to describe A and a way to describe B. So now if we do Pythagorean theorem, which is a squared plus b squared equals c squared, I can see that our a squared, if we square it, we don't have to worry about the absolute values anymore. So it's going to be that a value squared plus our b value, y minus k squared, equals c squared, which is r squared. And this is actually the standard form of a circle. All right, so here you can see the equation that we just derived. So again, x minus h squared plus y minus k squared equals r squared. So HK is going to be the center, which is what we used in our derivation, and R is the length of our radius. Now notice that the equation is r squared, so if you're trying to find the length of the radius, you do need to take the square root of this value. Okay, so first we're going to see if we can write an equation of the circle with the following characteristics. So here we have a center at 5, -1, that's going to be h and k, and our radius is 2 root 5. So we are going to want to find that r squared value. So when we're doing r squared, we have to square the 2, which becomes 4, and we have to square the root 5, which is 5. So our r squared value is actually 20, and now we just plug in what we have. So x minus h squared plus y minus k squared equals r squared. And there you have it. Okay, let's try one more. Here we have the center at -2, 5, and it's just containing the point -2, -1. So let's set this up. So we know this is h and this is k. We don't know r yet, but we can find it. So let's do x plus 2 squared plus y minus 5 squared equals r squared. And if we substitute for x and y, we can actually solve for r squared. So again, I'm going to substitute x and y. So here we have -2 plus 2 squared plus -1 minus 5 squared equals r squared. This you can see becomes 0. This becomes 36. So our r squared term is 36. We don't actually need to solve for r because we want it to be r squared. So then we just go back and plug it back in. X plus 2 squared plus y minus 5 squared equals 36. And there you have it. Now we're going to practice writing an equation in that standard form so we can then graph our circle. So we are going to need to complete the square twice because we have the binomial squared for x and for y. So to do this, I like to first group my x values together and then group my y values together, and then I like to move my constant to the other side. Now here I can't complete the square until we factor out that variable of 4. So I'm going to factor out 4, and we have x squared plus 2x, and then here I would add 1. That's the magic number that's going to complete our square. And then here let's factor the 4 out of our y terms, leaving us with y squared minus 4y. And then the number that completes our square here is 4 equals -11. Now here we need to make sure our equation stays balanced. So here I added 4, and then here I actually added 16. So now we can factor. So 4 times x plus 1 squared plus 4 times y minus 2 squared equals 9. Okay, so this is not quite in standard form because for a standard form, we shouldn't have any coefficients in front of our binomial squared. So we're actually going to divide both sides of our equation by 4. And then we should end up with this. So this is the standard form of our equation. So that means that our center can be found at -1, 2. And if r squared is 9/4, that means that r is 3/2. So here's how you can graph a circle. Start with your center, and then you're going to go the length of your radius, you're going to go directly to the right and left, and then directly up and down, and then you can connect those to make a circle. So we're going to go to the right 3 by 3 halves, and to the left by 3 halves. I'm going to put a little curved mark, up 3 halves, down 3 halves, and then we can just do our best to turn that into a circle. And there you have it. Okay, here's the last example for this video, so please pause and give it a try on your own, and we'll check your answers in just a few moments. Okay, go ahead and check your work here. So after you've rewritten it in standard form, you should get x minus 3 squared plus y minus 4 squared equals 16/9, which means your center is at 3, 4, and the length of your radius is 4/3. So your graph would look something like this. All right, that is all for today's video. Thank you so much for watching.